Hello everyone. So let's do another example. So here it says find the relative max and min of the function h of x equals x squared over 4 minus x. Okay, so relative, again, just also means local. So when it says relative max or relative min, it means local max or local min. So it's just another word for saying the same thing. So we're going to do the exact same thing where now we're going to find the critical points. So we're going to take the derivative here. So using quotient rule, it's the derivative of the top times the bottom minus copy the top times the derivative of the bottom, and then all over the bottom squared. Okay, so this gives us 2x times 4 minus x squared, and then times the derivative of 4 minus x, which is negative 1, and then all over 4 minus x squared. Okay, so now if I distribute this out, okay, because now we're going to have to be simplifying algebraically our derivatives because we need to be solving equations. Okay, so now simplifying this, I get 2x times 4, which is 8x, and then 2x minus x gives me negative 2x squared, and then negative x squared times negative 1 is a positive x squared, and then all over 4 minus x squared. Okay, and then combining like terms here, I get that this is 8x minus x squared all over 4 minus x squared. Okay, so now what I'm going to do is I'm going to set the numerator equal to 0 now that I have my derivative. Right, so this is my derivative. Okay, so to find when the derivative is equal to 0, I'm going to set 8x minus x squared equal to 0 and solve for x. So this gives me, factoring out the GCF of x, I get that this means x is equal to 0, and then 8 minus x equals 0. So I have the critical points x equals 0 and 8. Okay. So for fractions like this, remember when the numerator is equal to 0 is helping us in this case, since the derivative is the fraction, we're finding where the derivative is equal to 0. So we're trying to find when the numerator is equal to 0. Okay, so we found those critical points. Now we're also looking for when the derivative is undefined. Okay, so when is the derivative undefined? When the denominator is equal to 0. Okay, and so you could take the square root of this, but make sure when you do that you do plus or minus. Another thing that I'm going to point out is that this is equivalent to this. So hopefully you can see that 4 minus x squared is the same thing as 4 minus x times 4 minus x. And then that way you just see that you get, in both cases, when you set each piece equal to 0, you just get that x is equal to 4. Okay, but now you want to be careful here. You want to check that 0, 8, and 4 are actually in the domain of the original function. So going back up here, right? When I plug in 0, I get 0 over 4, which is 0, so that is in the domain. When I plug in 8, I get 64 over negative 4, which is negative 16, which is in the domain. But what about when I plug in 4? When I plug in 4 into h of x, I get 16 divided by 0, which is undefined. So this is not a critical point. Okay, and that's because it's not in the domain of h. Okay. So x equals 0 and x equals 8 are the critical points. Okay, so now this is kind of the weird part though, okay, when we come to the number line. Okay, because this is a little weird that I'm about to say that we are still going to include this number 4 in our number line. The reason being is even though it's not a critical point, it's a point where the original function is undefined. But in particular, if you recall, this is actually the location of a vertical asymptote. Okay, because to find the vertical asymptotes of rational functions, as long as it was in simplified form, which it is, well, looking at back at h of x, right? X squared divided by 4 minus x, I can't factor and simplify any further. So to find the vertical asymptotes, we would in fact set the denominator equal to 0 and solve for x. And so 4 is the vertical asymptote of this rational function. So if we don't include it on the number line, what's happening is it might not give us an accurate indicator of where it's increasing or decreasing to the left and to the right of the vertical asymptote unless we include it in the number line. Okay, so even though 4 is not going to be the location of a local max or min, because it's not a critical point, we're still going to include it in our number line because we do want information as to where it's increasing and decreasing, and we don't want that to mess up what's happening very close to the left of 8, okay? To make sure that we get a true understanding of if 8 is a local max or a local min or neither. It may possibly give us the wrong answer if we do not include 4 in our number line. Okay, so make sure that we do that, in this case for rational functions. So this is typically something that happens for rational functions. Okay, so I'm going to have my number line here. I have 0, I have 4, and I have 8. Okay, and then remember, I'm just going to like highlight this, or I don't know, make a note or something. I'll highlight it in red because this is not a critical point. Okay, so you don't need to check it later if it's a local max or min. Okay. So now I want to plug in numbers inside each of the interval. So looking in between negative infinity and 0, I need to plug in something. So I'll plug in -1 into the first derivative, plugging in 1 in between 0 and 4, plugging in 5 in between 4 and 8, and then plugging in 9 in between 8 and infinity. So these are things I'm picking here. And then now going back at my derivative, I have that this is going to be 8 times -1 minus -1 squared all over 4 minus -1 becomes a +1 squared. Okay, so this gives me -8 minus 1 over 5 squared. Okay, and this is going to be a negative number. So this is going to be negative. Now going to 1, I have that this is 8 times 1 minus 1 squared all over 4 minus 1 squared. So this gives me 8 minus 1 over 3 squared, which is positive. Okay, and then 8 times 5 minus 5 squared over 4 minus 5 squared. That gives me 40 minus 25 over -1 squared. So this should give me a positive. And then now plugging in 9, I have 8 times 9 minus 9 squared over 4 minus 9 squared. Just making sure I'm plugging in that correctly. Okay, and then this should give me, what, 72 minus 81 over 25. So this should be negative. Okay. So now looking at this here, looking at 0, I'm switching from decreasing to increasing. So when I draw something that's switching from decreasing to increasing, this is a local min. And then switching from increasing to decreasing, this gives me a local max. So there is a local max at x equals 8, and then there is a local max. Oh, sorry, local min at x equals 0.